Hello there. So today we're going to check how we can predict the loan. So basically, we're going to check whether someone is able to pay back their loans based on some features and some of their in like their incomes or their marriage statuses and their dependents and all those other things. So we are going to start. I have this data set. I have downloaded it from Kaggle, and as you can see, it's right here. I will provide it. Don't worry about it. So let's start. First, I'm going to import the also I have opened this Jupyter notebook you can download from online. It's really helpful in the modeling and the training models and data visualizations and data science. So it's really helpful if anyone of you want to use, but it's your choice. Anyways, so I'm going to import the pandas, and I would need to import NumPy. I'm going to show you why I'm importing NumPy. So just wait for a little bit. So I'm going to say read the data, the sorry, read the data set which I have it, and I'm going to say what its name is, loan data set. So loan dataset.csv. So if I read the head of it, you will know what columns do we have right now. So as you can see, we have the loan ID. You can ignore this; it's just an ID. We have gender, marriage status, dependents, how many people are dependent on a single person, the education of that person, is that person self-employed or not, applicant income, then it's like the side business or the passive income. This one, the applicant income. Then we have the loan amount, how much loan that person took. Then the loan amount term. Then we have the credit history, property area where he is living, he or she is living. Then we have the loan status. So this is our target. We are going to predict this one, whether based on these features. Like for example, this person has these features. I don't know who he is or she is. So is that person able to pay back their loan? So the actual answer is yes. But how can our model predict that? We are going to see that. So first of all, I'm going to check the total null values in the data set, because null values are really harmful for our data set, for our model training. So the first step was data extraction. We have extracted data from Kaggle. The second step is data pre-processing. So we are going to pre-process this data. As we can see, we have a lot of null values. We have gender, married, then we have dependents, self-employed, loan amount term, and then credit history. So a lot of them. So we're going to fill all of them with some values. So for the gender, let's check how many genders do we have here in the data set. If I say unique, that would give me the total amount of unique genders in our data set. So let me check it. So as we can see, we have the male, female, and NaN. So basically, the NaN are those values that are empty, and we are going to fill them. So let's see how we can do that. So what I'm going to do is I'm going to say dot fill. So I'm going to fill the null values in the gender column. I say fill NA, and then I say how do you want to fill it? We are going to use the NumPy to choose randomly from any of the genders, right? So I'm going to say np dot what do we have here? Random dot choice. Yes, choice, and then we're going to pass an array of male or female, and then I will say in place. So in place basically changes the original data set. So I'm going to say true, and then I'm going to run this. So now let's check if the genders are still empty or not. So as we can see, genders are uh, completely filled. So now we are going to do the same for merit. So first of all, let's check how many gender do we have. Sorry, the how many statuses do we have for the merit, right? So I'm going to say unique. We have yes, no. Okay, so only yes and no. So I'm going to copy this one, and basically what I'm going to do is I'm going to say, sorry, I'm going to say merit, and then I'm going to say yes and no. Let's make sure that it's capital or small. Okay, so that's good. Yes or no. So it will randomly fill it with either yes or no. It doesn't matter whatever the value is. We are not concerned with it. So we're going to run this. Although if we look at the real world problems, you have to check a lot of things. You cannot just assign random values to it, but we are just practicing. So it's okay. And then we have dependents. So for the dependents, we have three different type of dependents. If I check it, let me show you. Dependents dot unique, right? If I do this, uh, you will see that we have 0, 1, 2, 3. Sorry, there are 4. So we have 4 different types, right? The NIN is just empty. So maybe a person doesn't have any dependents. Dependents are basically those that he provide for. Like for example, a father provides for his family. So maybe his family includes one person, two-person, or more than three. So that was basically a dependent means. So we are going to do the same thing with it. We are going to fill it with these four random values. And then I'm going to say dependence, and I'm going to say 1, sorry, 0. It can be 1, it can be 2, or it can be 3 plus, right? So let's do this and then see what happens. Okay, so it's also done. Next we have, I don't know why I have done this mirrored thing two times. I'm going to cut this one. Wait, let me just, okay, so we are good. Now we have dependents are also done. Then we have self-employed. So self-employed is either no or yes. Okay, so we are going to do the same for this one too. We're going to say dependent self-employed. So it can be either zero, sorry, yes, or what was the second? No, right? So what do we have next? Next we have the loan amount. So loan amount is an integer value, or you can say float. If we check it, loan amount, as you can see, it's float. So basically, we can take the mean or the average of the whole of the data set, like the loan amount, average of the loan amount in the data set, and then what we can do is we are going to assign it or fill the empty values with it. So loan amount, then I'm going to say mean. So mean basically calculates the average of it. So if any one of you don't know how to calculate average of something, I'm going to give you an example. For example, you have 1, 2, and 3 values, right, in a data set. So what you're going to do is we are going to do this 1 plus 2 plus 3 divided by what are the total sum of it? 3. So there are 3 total values. And if you sum all of them and then divide them by the total amount, that's what average means. So we are going to do that. And once that is done, then we have long term amount. So we are also going to do that. We have loan. It's also an integer value. I can show you. Sorry, a float value, loan term amount, as you can see here. So we are going to fill it with the mean value of the loan term amount. Okay. And then what do we have next? Credit history. So credit history is either 0 or 1. As you can see, it can be 0 or 1. But to be sure about whether it is really 0 or 1, we are going to check the unique values in the credit history. Credit history dot unique, maybe it's 0 or 1, yes, so it's basically 0 or 1. So we can say that we can choose the choice one, right, as we did before, because it's a choice, either 0 or 1. It's not a float value that can change. So credit history random can be 0 or 1. So if I run it now, if I check the total, as you can see, all of these values are filled. So we are good to proceed. Now the next step is, as we can see over here, if I check the data set again, uh, so we are going to separate features and the target. So our target is this one right here, loan status. This is our target. We want to predict whether a person is able to pay back their loans or not, right? And all those other properties that we see here, those are our features of one single person, right? So some of these features are strings, as you can see here, they are strings, and some of these features are numbers. So numbers are fine, we don't need to change them. But for the for the string values, which have, like, for example, male, female, yes, no, or you can say graduate or not graduate. So these values, they need to be changed into integer, and by integer I mean 0 or 1. So it cannot be like because model cannot read strings, you have to convert them into binary format, 0 or 1s. So before we do that, I noticed that the dependent column is, although it's 0 or 1, so if I check the data type of the dependents, uh, the data type of it. Although it's 0 or 1, as we can see there, so it should give us either float or integer, but it's not going to give us. So its data type is object. Why is it? So if I check the unique values in it, there is some value. If I check it, as you can see, 0, 1, 2, 3 are fine, but we have this value, which is 3 plus. So it's a string. All those other values, they are integers, but this value, it's an object. That's why it's giving us this type of object. So we are going to change this because we don't want miscalculation or an error during model training. So the way we can do that is change it to 3, simple 3, right? We can do that. There are a lot of other ways you can try, but basically we are not sure how many numbers above 3 are there. So we are just going to assign it 3. We are going to replace the 3 plus with 3. So the way we are going to do it, we are going to say dependents dot apply. So what does apply do? Apply basically applies a function on each and every single uh, entry in the dependents column. So it will apply it on this one, then this, and this in all of them. So I'm going to say lambda. It's a lambda function. It's a short format of using a function x. X is basically a single entry like 0 or 1. And then I'm going to say if x double equals to 3 plus, right? If that's the case, no, I think this is not how the this works. I would say x if x is not equal to 3 plus 1. So keep x like 0, 1, 2. Keep them if they are not equal to 3 plus. Else the that would be simple 3. Right? Let's run it and see what happens. Okay, so I think it worked as you can see out here. I need to put in place over here if I'm not wrong. No, that's not. Oh yeah, so basically what I'm going to do is I'm going to assign the dependent column of it to this new, right? So now if I check the unique values in the dependent dot unique, if I check it, you will see some change. Like the 3 plus, it would be gone, and we would see something different. As you can see, 0, 1, 2, and 3. So it's basically changed. But as you can see that these values 0, 1, 2, and 3, they are still in the string formats, but I think it's okay. We can proceed with it. There is no problem with it. But before that, we had plus sign, which was really causing an issue. So right now, as that problem is solved, we have this thing called as gender, right? So it's a string, so we need to convert it into 0 or 1 format. So the way we are going to do it, we're going to use one chord. Wait, let me show you one key, one hotkey encoding. I think one hotkey encoding. Yes. So this is basically a method in machine learning where you can convert a string into 0 or 1. So basically, if I say column is either 0 or 1. So that means that if the value of the column male is 0, that would means that the gender of that person is female. If it is 1, so 1 stands for true and 0 stands for false. So it converts it basically into binary values. So let me show you what I'm trying to say. Gender uh, dot, I think it's get dummies. No, it's panda dot get dummies. I think it's something like that. I don't remember the method. Yes, it's get dummies. So I'm going to pass the data. Data is data frame, and then have the columns. Columns is gender, and then if I run this, as you can see, the gender column is gone. And if we scroll to the right, we can see that we have two other columns. Gender is gender male, gender female. So the first person, it has 0 and 1. So what does this mean? That 1 stands for true and 0 stands for false. So this means that the first person has gender of male. The second person is also male. And so if you look at this one, it has 1 0 value. So this person has a gender of female. So it converted it into binary values, right? So this is really helpful for the machine. And I'm going to drop the first one. The reason I'm going to do that is because we can just use the second column, which is gender male. So it will basically indicate whether 0 or 1. Like for example, for this one, let me show you first. Okay. So I dropped the first one, as you can see here. The gender male, gender female is dropped, and I only have the gender male. So basically, as you can see that gender male 1 1 1, and whenever there is 0, that means that that person gender is female. Other than that, that means that 1 stands for male and the 0 stands for female. So that's basically one hot encoding, one key hot encoding. I don't remember its name. It's very confusing. So next we are going to do is we are going to assign this to a new function, right? And we are going to do the same for the merit, right? So we can do that for the merit column. So if I say merit, let's see what happens. So married also is also gone and it is converted into married yes. So is someone married? Married yes would basically be either 0 or 1. So is someone married? It can be either 0 or 1. 0 stands for no and 1 stands for yes. So now we have another column, gender, married, then we have education. So let me check how many values do we have for the education. As I'm not sure, maybe there are more than two, which would be we are going to try a different way for that if we have the more than two values. So we have only two values, so we can also include the education here. uh, it's going to give me an error. I knew it. I know, I think it's going to give me an error because those columns are gone and it cannot detect those columns. So I have to run all of this code again. That's kind of a stupid mistake, I would say, but mistakes makes it better. So now if I say df, I have another column called education not graduate. So what does this means that someone can either be graduate like zero, not graduate basically means that is that person not graduate. So zero means no, he is graduated. So one means yes, he is not graduated. So that kind of thing. And then what do we have next? Education. Then we have self-employed. So it's also yes or no, and have to run all of the code again. You know what? I'm going to mention all the things first, and then I'm going to proceed. So then I have the property area. It can be either urban or rural. Okay, there cannot be any other than that. So I will run all of the code again because I made the same mistake again. You know, I should have mentioned all the columns first, and then should have ran the. But anyways, so now if I see, this is our new data set. So this is the new column for the area urban. Is that person living in an urban area? One means yes, zero means no. You know what? Why is I think the urban column has more than two values. If I'm not wrong, wait, where is it? Uh, that's why it's giving me property area, urban and semi. You know what? Let me try to run it again. No, uh, I'm going to tell you what I'm trying to say. But first, let me. Where is that code? So this is it. Okay, so I'm going to check the unique values of the property area because I think there are three values. That's why it's giving us two columns. Yeah, you see, there are three values for the. So for the urban, we are going to do something different. So the way we are going to do is we are not going to drop the first one of it because we have three values and we have to specify the three for each one of them. We can drop the first one, but that won't be really helpful for us. So what I'm trying to say is that if I run this and then if I say df, so now we have three columns for urban. So a person can either live in each, cannot live in each one of them. So it can be either one of them. So for example, the first person, he is living in an urban area. The second person is living in a rural area. The third one in urban, and so on, right? So zero zero, it's like the logic gates, right? Zero zero one, wherever one is, that means that gate is true. So that kind of thing. We are not going to convert this one. As we can see, we have all integer values except this one. Why is it not converted? Not sure. Although I have dropped it. You know what? Let me check it again. It doesn't matter if it dropped it or not. We can still proceed with our these columns because we have those columns. We can ignore these one because though they contain what we can say strings. So now what I'm going to do, the third step is separating features and um, target. So our features are, let me check them. Mm, applicant income. Let me start from beginning. No, 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 no. These are all this is also string. This one is our feature. Then we have this one. I think all of the other ones are our features, right? Except for the loan status. I'm going to remove it. So I can copy all of these. If I start. So all of these are yeah, so there are a lot of them, but that's what we are going to do. I mean, all those features mean something, right? Once we loan status is not over, that's our target. So once we complete the model training, then when we start testing it, then you will see what all these columns means, right? So right now it may does not make sense to you that whatever I'm doing, like converting the string values and the object values into integers, it may not any make sense to you. So just wait a little bit and then you would see what I'm trying to do. So now we have y, which is the target. And what is our target? Target is the what is it? Loan status, right? Loan status. So I'm going to run it. And then what I'm going to do is I'm going to split it. So from we have this function in the scikit library called as train test split, which basically splits data into training and testing data sets. So import train test and split. And train test split is basically returns these values x train, then we have x underscore test, we have y train, then we have y underscore test, right? So we are going to say train test split, then I'm going to pass the features and the target. and then I'm going to specify the test size, which is 0.3. So we're going to take the 30% for the testing purposes and the rest of the 70% for the training purpose. And I'm going to say random state is equal to, let's say, 101. So you can specify any random state, it doesn't matter, it's just a number. So now if I check the X train, it's basically some data that has been splitted. As you can see, randomly splitted. As you can see, the numbers are randomly. If I check the Y contains the yes or no column of the loan status. So it's also random specified, as you can check the indexes over here. So anyways, the next step is the modeling, right? So we are going to import we are going to use the random forest classifier. So you can go to the sklearn or the scikit-learn library where they have all the documentation for the random forest. So basically, random forest is a combination of trees, which is used for the classification of the data set or the model. Like for example, we want to classify the whether the loan is yes or no. We can also use logistic regression, but a random forest is really fast for bigger data, although it is really complex, but it's really fast for bigger data, and its accuracy is a lot more than the logistic regression. So we are going to use this one. So it basically goes like the trees, like for example, searching for a single person, it will go into different branches and search for the output of that person. So I'm going to declare an instance of it. Random forest classifier, and then I'm going to run it, and then I'm going to fit the data to it. And so fitting data basically means training it. So what is our training data? X train. If I check the documentation of it, it says that I have checked it. I don't know why it's not working right now. A shift tab basically tells you the documentation of the function. So if it basically trains your data, it takes the X train and the Y train. So let's hope that it works. Yes, it worked. So now I'm going to take the predictions from the whatever it predicted. The model has predicted. I'm going to say model dot predict. So I'm going to so it takes one single value which is X, and we have the X test which we reserved for the testing purpose. It's at 30%, if you remember. See right here. So I'm going to do that. If I check the predictions, it will contain zeros and ones. What are those zeros and ones? Basically, these zeros and ones are for the X test. Like it says that for the first person which has this data, the loan status is yes. So that's what it's saying. It predicted it itself. It didn't look um, for the actual data. So now we are going to check the metrics. So what do I mean by metrics? Metrics is basically the evaluation terms or methods that are used for the model. So I'm going to import two of the functions. The first one is the classification report. The second was the confusion matrix. It basically calculates the accuracy of the model. So I'm going to say print classification report, and then I'm going to pass. It takes two arguments. So the actual values, y true means the actual values, and the predictions. So the predictions that it did, as you can see here. So the actual values are the y test, and the predicted values are the predictions, right? So I'm going to run it. So as you can see, its accuracy is 75%, right? Which is not bad. This is pretty much good. I cannot say it can be applied to real world cases or not, because 75 for the real world case is a little bit low. It should touch at least 85 or 90. But anyways, it's just testing. You can try with different data with different techniques. You can use the thing that I used over here uh, for assigning the zeros and ones, one hot encoding, which I did somewhere. Yeah, here you can use standard scalar for it, or there are a lot of other methods, but that's a really common method. It's one of the easiest. That's why I used it. So if you can see that the accuracy of this model is pretty good, the sum of these two values I have mentioned in my earlier videos should be greater than these two. So that means that your model is working fine. So now let's test it. So we are going to test it on a test person. Like there is a person. We don't know about anything about him. We all we know is these features, right? So these are the features about that person. Let me just hover on. So these are the features about that person, and we are going to pass it to the model and tell him that, you know what, we know about we know these features about a single person, about a single person. Can you tell us whether that person can pay back his loan or not? The model will predict it based on these features. Let's say the applicant income is he's earning like 5,000 a month, right? So we can say that he's also earning $200 from passive income, right? And the loan amount that he took is $10,000, right? And the loan term, let's say, is 300. I'm just giving random values. You can give any values. It doesn't matter. So the credit history can be either one or zero, right? So I say, you know what, his credit is good. One basically means good and zero means bad. So then I can say property area rural or urban. So this is where what I was talking about. So the person can either live in these three of the cities. He cannot live simultaneously or at the same time in all of these three positions or at these three locations. So let's say the person is living in the uh, urban area, right? So I could say one, and for the rest of these, I will pass zero. So that's kind of a and condition, or you can say over condition. I'm not sure. So now we are going to create a test data frame. So I'm creating a test data frame because model does not accept simple dictionaries. You have to convert it into a dictionary, um, into a data frame. So if I check it, this is what the model has. I don't know why I didn't do the gender thing. I missed it, I guess. As you can see here, I think I should have mentioned it. This was the where is it? The gender things. I don't know why I missed them because they were really important. And but you know what? You can skip it for now. You can use it later in if you want to explore it. You know, you can use the gender. Although I converted them, I don't know why I didn't use them. It's really kind of messed up situation. I would say. I don't know. See, model data, and then we have database. So you know what? Let me just copy this one before this. I'm going to run it again, okay? Because I don't know why I missed those columns. They should be there. But if they are still not there, we can ignore them. Okay, so this is done, this is done, this is done. Yes, is not an index. Property area is not an index. Where is it? Okay, so we are converting property areas two times. So let's see if we can do something again with it. It's going to be a very lengthy process, I know it, but you know, I just made a silly mistake and I have to. Okay, so now this is the. I don't know why I missed them. I really apologize to you guys. I think uh, I shouldn't have missed them. But anyways, these are the columns. This is the gender one, the married and not. So we are also going to include them in the features. So they are one of the most important features. I still don't think that the model should work without these features. It will work, but you know it is not supposed to work because these features are really important. Someone is married or not married because his salary depend on this, right? And someone is graduated or not graduated. There's also kind of a very important factor in employment is also a very important factor in determining loan status of someone. So now I think we are good. So let me check it again. Now what's happening? Education not is in the okay, so we are doing some error over here. Where is it? Yes, over here. No, not here. Education not. Oh, so these are single columns, right? Okay, so now it's fine. And then we can do this. Run the whole code again. Let's see what happens. So predictions this. Okay, so now its accuracy is dropped because of those extra features that I added. Anyways, so there's the kind of thing that happens sometimes. So we have copied all of the values except these one, right? The gender, male, the married, and the self-employed. So we are also going to add these features to the test data of that person. Where is it? Here it is. So we are going to say that, let me just format these first. Okay, so gender is male. Yes, it is male. So one. He married? Let's say no, zero, right? Is he educated? Yes, he education, not graduate. No, no, he is graduated. So we're going to say zero, right? So zero would basically means that he is graduated because here we can see that education not graduate. If I provide one, that would means that that person is not graduated. And then we have self-employed. Yes, he's self-employed. So now if I run it, we have some extra columns over here on the right side. Now let's predict the loan status of that person. So model dot predict, and then I'm going to pass the test df, test data frame. Yes, that person can pay back his loan. You know what? Let's change some certain things. Let's say that person is earning 50, which is really kind of an impossible situation, but let's assume it. And that person side income is, let's say, 100, right? And credit history is really bad. And he lives in a semi-urban area, not urban. And then gender is, let's say, male. Is he married? Yes, he is married. And I also missed another column, if I'm not wrong, which was dependent. So I really apologize. I don't know why I'm missing these, but you can use these columns as I added before. Okay, so is he graduate? No, he's not a graduate. Self-employed? No. So everything is bad for him. Let's check if yes. So as you can see, based on those bad features, that person took $10,000 loan, and he is only earning 50, like $150. So he cannot pay it back. So that's why it's saying n, which basically means no, he cannot pay it back. And if you want to print this value, only the n, you can say 0, and that would give you the n simply. So that's basically what loan prediction system is. You can predict someone's ability to pay back their loans based on some certain features. As I said before, I did not use this column because I missed it again for some reasons. You can add it here. Where is it? Right here. You can add it. It's really simple. I might have missed it for some reason. I don't know. I'm not sure. Yeah, here it is. So you can just copy and paste it here and then use it again. But anyways, this is how you can predict uh, someone loan status. And yeah, that's basically it. I will provide the code and the relevant documentation or the data sets and all the code. And if you have any questions, please let me know. Okay, thanks.